Welcome to this urgent explainer briefing. Look, if you're a military defense analyst, this is the intelligence you absolutely need to process right now. Bottom line up front, warfare is rapidly shifting from reactive human speeds to predictive AI autonomy. We're not talking about future hypotheticals anymore. We are tracking active, on-the-ground deployments that are literally rewriting the rules of engagement.
Let's jump right in by comparing traditional human target identification speeds against our new modern AI-driven metrics. Historically, a traditional digital target pass took a staggering 743 minutes. That's over 12 hours. But during the Army's Scarlet Dragon exercises, the AI Maven smart system pulled that exact same process down to less than 1 minute. It's not just a faster process, it's a fundamental shift in how quickly a military can act on intelligence.
Here's our agenda for today's explainer. We're covering the new operational tempo, rapid battlefield data triage, the autonomous operator, space and predictive intelligence, and finally, human versus AI metrics.
Section 1. The new operational tempo, collapsing the sensor-to-shooter cycle.
To really grasp this hyper-accelerated battlefield, just look at the personnel footprint. A tiny team of just 20 soldiers using AI can now completely replace the output of a 2,000-person legacy cell. You're taking thousands of human operators entirely out of the loop and swapping them for a highly streamlined unit that's processing 1,000 targets every single hour. The efficiency multiplier here is absolutely astronomical. By combining real-time AI feeds, we're drastically accelerating the sensor-to-shooter decision cycle and improving precision. We're talking about first-person view drone strike accuracy jumping from a coin toss 30% all the way up to an incredible 80%, and that detection-to-destruction timeline cut to just over 30 seconds. But we have to talk about the vulnerabilities here. At this kind of hyper-speed, things like electronic warfare jamming or algorithmic false positives can trigger catastrophic misfires way before a human operator even has the chance to intervene.
Moving on to Section 2, Rapid Battlefield Data Triage, Managing Information Overload.
In active combat zones, rapid data triage is absolutely critical because information overload can paralyze decision-making just as fast as a kinetic strike. The scale of real-time threat identification has been completely redefined. Historically, human officers generate about 50 targets a year. Compare that to Israel's Gospel AI system, which outputs over 100 targets per day. But listen, this level of AI reliance carries immense risk. If the underlying data is flawed, we're basically rubber-stamping lethal targeting at a volume that entirely outpaces our capacity for human oversight. And you know, this rapid triage isn't just happening with missiles and drones. It's happening deep within the networks. AI security operations centers are now handling 90% of routine cyber warfare triaging. That frees up human operators to focus on the strategic calls that actually matter. Just look at the Pentagon's Secure AI Workspace, G9 It hit 1.1 million users in 2 months with zero downtime. And over on the administrative side, the Army used AI to update 300,000 personal records in 1 week, saving 50,000 human hours. That's time handed straight back to human strategists.
Section 3. The autonomous operator, from assisting to executing.
We are now entering an era where the machine literally takes the controls. Let's look at some highly successful test results from the Air Force's Vista X-62A aircraft. It started with early dogfight simulations, executed 21 initial test flights, and then operated continuously for 17 hours across 12 flights. The climax here is staggering. These AI-controlled agents achieved a perfect 5-for-5 win rate against experienced human F-16 pilots in live dogfights. We're seeing this exact same autonomous escalation out at sea, too. Take the Nomad unmanned vessel. After deployment, it traversed 4,421 nautical miles, and get this, it operated in autonomous mode for 98% of the entire trip. The need for constant human steering across our oceans is evaporating, and it's happening incredibly fast. Grounding this in live combat, autonomous AI weapons are already central to modern warfare. The statistics out of Ukraine report that 80 to 85% of frontline targets were engaged by unmanned aerial vehicles. We're talking 215,000 strikes in one summer alone. The reliance on these autonomous drone operations is expanding at an absolutely unprecedented rate on the battlefield. Section 4. Space and Predictive Intelligence, the ultimate vantage point. When we shift our vantage point to space, AI's pattern-finding ability translates directly to military overmatch. Just consider the sheer scale of this orbital management metric, 144,440. In just 6 months, AI executed over 144,000 collision avoidance maneuvers for Starlink satellites, completely without human input. Pair that with nearly 85,000 autonomous propulsion maneuvers, and it's clear these satellites are seamlessly managing themselves. And think about how satellite-based autonomous navigation is going to change future global logistics operations. When you apply this predictive power back to Earth, it completely upends current supply chain timelines. What traditionally takes weeks of human logistical planning can now be optimized by predictive AI modeling in a matter of seconds, paving the way for continuous, autonomous global resupply. And back on the ground, AI's predictive power is just as immediate. Right after the Taiwan earthquake, AI mapped 7,000 landslides in just 3 hours. That is the kind of lightning-fast predictive analysis that our current defense and disaster response frameworks are starting to rely on heavily. This massive pattern-finding speed is exactly what militaries want for remote intelligence gathering. We're seeing AI process a full month of complex LIGO data in under 7 minutes, finding 4 black hole mergers. It flagged over 1,300 Hubble image anomalies in just 2.5 days. And maybe most impressively, it's allowing rovers on Mars to autonomously choose soil targets and correct their own laser focus with 93% accuracy. It proves these machines can adapt in the most isolated, high-risk environments imaginable.
Section 5. Human versus AI metrics. The point of no return.
Synthesizing everything in this intelligence briefing, here is the stark reality. AI is no longer just assisting systems, it's actively keeping them alive. We've crossed the threshold where AI is ensuring system survival. Whether it's dodging orbital debris or rapidly identifying incoming threats, the machine is no longer waiting around for a human to tell it how to survive. Which leaves us with this final provocative thought to consider. When the machine operates faster than human comprehension, how do defense analysts adapt to being completely out of the decision loop? The data is crystal clear. AI is faster, it's more precise, and it doesn't get tired. So what happens to the human role when we are essentially forced out of the operational loop? Keep that in mind as you evaluate the defense landscapes of tomorrow. Thanks for joining this explainer briefing. Keep analyzing the data, and we'll catch you next time.